Hello everyone. Now we are going to see about common source stage with current source load. So in the previous video we have discussed about common source stage. Now we are going to see that common source stage is connected with current source load. What will be the gain and impedance, input impedance and output impedance. This is what we are going to see now. So here this is my transistor, NMOS transistor. That is also common source type. This is common source because source is connected to ground. At the gate is at the gate side we are giving input, at the drain side we are taking the output. In the previous common source diagram, here instead of this transistor we have placed one resistor, load resistor. So here PMOS transistor replaced that resistor. This will be acts as a current source load. Current source PMOS transistor, this will be acts as a equivalent current source. This is nothing but one current source. This is a diagram for common source stage with PMOS device as a current source. Here PMOS device will be acts as a current source, and this is what the equivalent small signal model. Here for M1 transistor I am having here channel length modulation is considered. If you are considering that, there will be a output resistance RO1 at this M1, and next here what is happening is M2, this M2 simply behaves, this is M2, so this is transistor M2, this simply behave as a resistor that is equal to its output impedance, GM output impedance, that is GM to V1. Here we are considering V1 equal to 0, so GM to V1 also will become 0. So at this drain node of M1 sees both RO1 and RO2 to AC ground. So what will be the AV, that is gain, that is equal to minus GM into RO1 parallel RO2. This is what my gain. And then what is my output resistance? ROut equal to RO1 parallel RO2. This is what about common source stage with current source load. So next we are going to see common source with diode connected load. So in the previous case, instead of load resistor we have connected one PMOS transistor that acted as a current source. Here that is replaced with one NMOS transistor. This is called diode connected load. So how this will act as a diode? Here your NMOS transistor gate and source both will be connected together. So this will, here I am having drain at this side I am taking the output. So here the gate and source both will be connected together. So this will be acts as a two terminal diode. So what is the equivalent small signal model M1? I am considering channel length modulation. So RO1 that will be added here, and this is equivalent to this load, that is diode connected load will be equivalent to one resistor. I am writing that resistance as 1 by GM2, and here we are considering channel length modulation. So in parallel we will be having RO2. This is what the small signal model of common source stage. And next here what is the gain? So gain is equal to minus GM1 into Rout. So what is my Rout value? This is what we are going to find. GM1, that is nothing but transconductance of input resistors M1, and here M2 acts as a small signal resistor. So now we are considering our channel length modulation is 0. So we are neglecting channel length modulation. So what will be your output resistor, that is load resistor, that is equal to 1 by GM2, and we can neglect RO1 and RO2 since lambda equal to 0, that is channel length modulation is 0. So these both two will become infinitive, so we can remove that. So your Rout will be equivalent to 1 by GM2. Then what will be your gain? Gain is equal to minus GM1 into Rout. Here we are having minus GM1 into Rout. So AV equal to minus GM1 into Rout is equal to 1 by GM2. So you can substitute that here, and we already know our transconductance equation root of 2 mu n Cx W by L into ID. Here I am having my first transistor transconductance M1, that is GM1, and my second M2 transistor transconductance, that is GM2. So I am representing this first one here, W by L of 1, W by L of 2. So you can substitute these two transconductance values here, and you can remove the common terms. Finally you will get AV equal to minus root of W by L of 1 divided by WL of 2. Then if you are considering channel length modulation, what will be your gain value? So AV equal to minus GM1 into 1 by GM2 parallel RO1 parallel RO2. So these two output resistance will be considered if you are considering channel length modulation. This is what about common source stage with diode connected load. So here we have discussed two different things. One is common source stage with current source load, then what is the gain and output impedance, and common source stage with diode connected load, what is the gain. This is what these two things we have discussed now. So if you are taking this common source stage with diode connected load, it exhibits moderate gain and this will give low impedance. This is the characteristics of, these two are characteristics of common source with diode connected load. Thank you for watching.